I think my video got cut off before, so I'm going to come back up to here where we were subtracting x squared plus minus 2x, distributing, and canceling factors. So the important thing to do now is to factor out the h. So whenever you have an h in more than one terms, you can bring it out. If I factor out the h from here, I'm left with 2x. If I factor out a single h from here, I'm left with just an h. And if I factor out the h from negative 2, I'm left with negative 2. Now the reason I want to do that is because I want to simplify out the denominator. Hopefully my denominator should always cancel out of my difference quotient if I did it correctly. Now notice this difference quotient has an h left in it. The earlier one didn't. You should always have an h left in it if you're working with a nonlinear function. So x is your starting point, h is your distance, and this is going to be your difference quotient here. So let's think about an actual example. What is this telling us? It's telling us the slope. If I draw a line connecting 2 points, this is going to tell me the slope. So let's imagine we are looking for x equals 1 and h equals 0.5. Before we do it, let me go up to the picture. X equals 1 is right here. H is 0.5 means that I'm going to go to 1.5. I'm going to go 0.5 away from my starting point, and I'm going to find that portion on the graph. So what I'm really doing down here is I'm finding the slope of this little connecting line here. I'm going to expect that it's positive because I'm going up in this little portion. I'm going 0.5 away from 1, so that's my h distance there. All right, back down to the example. Here's my difference quotient, 2x plus h minus 2. I'm plugging in 1 for x, I'm plugging in 0.5 for h. And when I work this out in my calculator, I get 0.5. That's a positive little slope. It corresponds to what I thought when I looked at my picture. So it's the slope from 1 to 1.5. And on the right side of the graph, I'm not surprised that I got a positive number, that it's increasing. It's just finding the slope, just a little bit different way of doing it. So let's look at another example. Before we do it, x equals negative 2, distance of 1. So let's go to our picture. Actually, negative 2 isn't even on here. If I guess it's probably, we'll just say it's here for now. Moving a distance, it's going to be somewhere around here. I'm going to be wanting, I'm sorry, it's really off because it's going to be up here. But it's on the left side of my graph. I'd expect it to be negative. So I'm going to really be looking from negative 2 to 1. H is 1. I'm sorry, negative 2 to negative 1. This distance for that piece of the parabola there. So here's my difference quotient, 2x plus h minus 2. I'm plugging in x, I'm plugging in h, I'm working it out. I get a negative slope. What is this? It's just the slope. It's the slope from the starting point of negative 2, moving a distance of 1, so negative 2 plus 1 is to negative 1. So the slope between negative 2 and negative 1. This is on the left side of the graph, so it's not surprising it's negative because our parabola is decreasing there.